Hello everyone, in this tutorial we will create vehicle yielding system so we can yield for other vehicle to proceed, and this system is decentralized. Each vehicle have their own decision and it's based on the right of way and first come and first go. By having this system, we can prevent the reverse behavior or recalculate the path at the intersection. Go to plugin, we call AI source, we call AI public, add a new file, name it vehicle yielding system .h. Yes, and copy this name, go to private, add another file, name it vehicle yielding system .cpp. And we generate Visual Studio project file. We open traffic tutorial.sln and then open vehicle yielding system.h and vehicle yielding system.cpp. Go to vehicle AI component base, copy this, pragma 1, include for minimal.h, include components Spline component.h. Include vehicle yielding system .generated.h. Class, we declare new vehicle AI component base. U class, no printable, class, vehicle AI API, new vehicle yielding system, public, we inherit from U object, generated body, public, new property, edit anywhere, blueprint read write, category, yielding equal yielding UV call yielding system pointer owner vehicle. Sorry, UV call AI component base pointer owner vehicle. And go to .cpp. Go to .cpp. We include vehicle yielding system.h. Include vehicle AI component base.h. Now go to vehicle AI component base.h and we add class U vehicle yielding system. And in this variable, we add the yielding system variable. So we can create the instance for this yielding system. It did anywhere. Blueprint retry. Category yielding. We call yielding system pointer yielding system. We call AI component base. We include we call yielding system.h and we create the yielding system instance. Yielding system equal new object we call yielding system. This we call yielding system static class. Then yielding system owner vehicle equal this, because we create inside this vehicle AI component base. Let's try run this. We have some error with this class. Delete.vs binary intermediate cell, and we generate Visual Studio project file. I spelled this yielding wrong. Build this, Control B, and this new object you will call yielding system. I spelled it wrong too. Save. Run this. And we can open the project, close it back, go to vehicle yielding system.h and add some variable. View property, edit anywhere, copy this. Category name is intersection. In next intersection action. So this next intersection action, we divide it into 3. Go straight, turn left, and turn right. Straight is 0, left -1, and right is 1. Copy this property. Float distance to next intersection. Add vector next intersection. Bool has next intersection. Public intersection management. Create a new function, bool get next intersection info, and we return in intersection action. Float return distance to intersection. Add vector intersection location. And we can copy this to this vehicle yielding system. And this is your vehicle yielding system class. If not owner vehicle, we get default spline from the owner vehicle. We need to check if it is not valid or owner vehicle actor return false. So it don't have the next intersection. Use Spline component pointer Spline component equal owner vehicle default spline find component by class use spline component add vector process intersection. So this is the closest intersection, not the next intersection. It is different than the next intersection. Following intersection. And vector intersection location on spline in closest intersection index next intersection index and find the closest intersection point and its index. Owner vehicle, we can go to this vehicle AI component base. We have a function this find closest point with index. To call this owner vehicle actor get actor location. Owner vehicle we get path node location and closest index intersection index. Closest intersection and now the one is closest intersection index. And then we draw the backsphere. Get where closest intersection radius is 300. Well, F color red for duration 0.0 thickness 20. So this next intersection index we don't have it yet, so we can comment on this. And we need the return intersection action set it to 0 first. 0 means it is straight. We don't turn. Distance to intersection is 0. Intersection location equal to f vector 0 vector and return true. We set this value just to debug. Let's draw the backsphere. And we need this hand node location. It is the point at the intersection from our vehicle location to the target location on the road. So go to road network tool, road actor.h and .cpp. Road actor.h. Use function find path road network. We return this path. Now we need to return path node location too. So for this void, right offset T array f vector path T array f vector path node location. We can copy this to road actor, find path road network, and we don't need this. True, delete it. And this is void. We delete this path because we already have it in output. This return, we don't need to return path, just return and call for loop for each path node on share pointer f path node. Path node path nodes. And add it to path node locations by get path node location. Path node is a struct that locate at the intersection of the road network. And when complete, we don't return this. Save. We close this road actor.h and .cpp. Go to yielding system and create new property. This category is yielding. Boolean to yield. Speed and movement control. Void update speed setting. So we call yielding system.cpp and we create that function void. We call yielding system update speed setting. If you remember from the last tutorial, we delete set min speed and set max speed depend on some condition. So now we need to implement this back. If not is valid, owner we call road network. If the road network is not valid, we set owner we call min speed to 5 and owner we call max speed to 100 and we return. If our vehicle not yet arrived at final target, has next intersection, we call this function get next intersection info, and we set to this variable next intersection action. Distance to next intersection and next intersection. Then if has next intersection, and next intersection action equal to 0, it means the vehicle will go straight at the intersection, and distance to next intersection less than 1000. We set max speed to slow down to 15. Owner we call max speed for 15. L owner we call max speed equal to owner we call actual point that we get from the speed trace at the along the spline path less than 3. It means it overlap the vehicle. So we set the max speed to 0, and if it's not, set max speed to 100, which is the default value. Owner vehicle min speed equal to owner vehicle and overlap, and owner vehicle S vehicle overlap, or B should yield 0 and 5. Cell vehicle AI component base, hit component, yielding system, and we call update speed settings. So when we call update speed setting, we also call this get next intersection info, and we draw this debug sphere of the closest intersection. Let's run this. Go to we call AI component. Find path road network, and we can move this a little bit. Set path node location, and this is the path. Compile. Go to VP traffic manager. This spawn temp vehicle 1. We only spawn one vehicle and don't set the target location. Let's play and see if our vehicle can find the closest intersection. So let's set this target, and now we can find the closest intersection of this vehicle. But the target speed is not yet correct. I will put the link in the description so you can download this file. Vehicle yielding system. Let's open this. We need this function calculate dynamic deceleration distance. We can close the project and save selected. I will copy the function so it is faster than I type it one line at a time. Vehicle yielding decision. Go to this vehicle yielding system and paste this. Vehicle yielding system.cpp. This vehicle yielding decision. Calculate dynamic deceleration distance. Copy this function as it about update speed setting. Sorry, this is not yielding. We call yielding decision. Copy this function. This calculate dynamic deceleration distance. We get the reaction time and deceleration rate. You can adjust this value as you want, and we convert vehicle speed from mph to centimeter per second, because in Unreal Engine they use centimeter as the default metric. Multiply with this value and divide with this, and then we calculate the dynamic deceleration distance by using the vehicle speed multiplied with the action time, add with square root of vehicle speed divided by 2 multiplied with deceleration rate. Return this value, and then we use this instead of fixed value of 1000. On vehicle speed, and we continue to create this next intersection info, because now we only have the closest intersection. Delete this. We can go to this function get next intersection info and copy this from path forward. Closest intersection index. We need next intersection index. Intersection index, and we can copy draw debug sphere. We paste this here, and we set this next. We set this debug to intersection location, which is next intersection location. When the intersection dot product is greater than 0.75, it means the next intersection we need to go straight. If it's greater than 0, we turn right, and if it's -1, we turn left. We can print string this, so we can see the code is working. Engine add on print debug message -1 5.0, color is green, text goes straight. Copy this, turn right. Another one is turn left. Save. We can set this duration to 0. Let's play. And let's play. If we set this target location, you can see the next intersection vehicle need to go straight and then go straight again. This intersection goes straight and this one goes straight too. And this one turn right and go straight. Next is turn right. Let's say this. This intersection we turn left and then turn left and then go straight. Copy another function is vehicle align with spline. Copy this. And copy this vehicle and spline alignment. And we copy next we need to add this variable, all of this yielding intersection. This is the location of the intersection that the vehicle is yielding vehicle, the array of vehicle that are yielding to our vehicle, crossing vehicle, the vehicle that proceed crossing the intersection first. Go to vehicle AI component base and speed trace. Find speed trace along spline path. This stop early. We need to check if yielding system B is our vehicle is yielding and road network is valid. Sometimes we drive outside the road network, so we need to check it. float intersection distance equal to line component get distance along spline at location yielding system yielding intersection location is spline coordinate space. Well, if sample distance greater or equal to intersection distance, subtract with road network road width divide by 1.5 we break. When we break, it means that we stop adding the tracing spear. So our actual point will be lower than expected point, and our vehicle speed will slow down. Next is capsule collision along spline path. If yielding system B should yield or distance we call to spline greater than point spacing divided by 2 or yielding system is vehicle aligned with spline component 30 we return. So if our vehicle is yielding, we return don't set this capsule collision along spline path. So other vehicle won't detect this capsule collision. It can pass our vehicle smoothly. Also with some other condition that our vehicle is not aligned with the spline in 30 degrees. And let's save. Go to vehicle yielding system.h of our project. Add another function. Vehicle yielding system. Void vehicle yielding decision. Float point spacing. Use vehicle AI component base. Overlap vehicle. a vector overlap location bool. B is capsule collision. We can copy this. If it's not valid, owner vehicle road network and we return. And decision, it's depend on three conditions. First is should yield. So it means that this vehicle is yielding to another vehicle. We can delete this print string because we will add multiple vehicles and this print string will confuse us. Copy this to debug sphere. We get owner vehicle actor, get actor location, radius 300 and red duration 0 and 10. It's thickness. The next is yielding vehicle is empty. So this means this vehicle is driving while others yield. So this means our vehicle is proceed the intersection first. And the last condition is normal driving. And let's add the variable private bool b debug yielding for to true. So we can enable and disable this debug. If this is true, okay, this copy, and this is yellow, and normal driving is green. We can call this vehicle yielding decision function Go to vehicle AI component base, and this be traced along spline path. Yielding system, point spacing, overlap vehicle, overlap location. B is capsule collision. Next, we can copy this function, resolve vehicle yielding status. Paste this here. Resolve yielding status. Copy. Paste it here under this. So this function, it happens when the green vehicle overlap with green vehicle. We find the distance between our vehicle to the next intersection. And the same with the overlap vehicle, we find the distance from that vehicle to the next intersection of that vehicle. And then we compare the distance. If we are closer, we should go first. And if other vehicle is closer, we should yield and other vehicle should go first. When we go first, we need to set current crossing vehicle if our own vehicle, and then we set the yielding system of other vehicle. Crossing vehicle is our vehicle, and other vehicle should yield to true, and then set the yielding intersection location. And our vehicle, we need to add yielding vehicle is the overlap vehicle. And this one is opposite of the first one. For resolve vehicle yielding status. When normal driving vehicle overlap with each other. Overlap vehicle. And like this. Open BP traffic nature. And spawn time vehicle 1. And we connect this. And we connect to spawn time vehicle 2. The test when two vehicle turn left and it have the collision area in one intersection. Play. And now one vehicle is proceeding and another is yielding. So this vehicle pass this vehicle, save and close. Copy, determine next crossing vehicle. Pay vehicle yielding system. Paste it. And another function is promote next crossing vehicle. The definition. Copy this. Paste it here. We don't need to sort it yet, so we delete this. We call this function when we are proceeding while other yield to our vehicle. Overlap vehicle. So this function, we check if our vehicle has the yielding location, the distance along the spline. So when we pass it, we promote the next crossing vehicle, which we get from yielding vehicle array. And then we remove our vehicle from crossing to normal driving, which is green color. Let's run this. Let's play. And this vehicle is closer, so it proceeds. And another vehicle yield after it has the intersection, and the vehicle will proceed. And it is working. Go to BP traffic manager. Call spawn temp vehicle 3. So this have 3 vehicles. Next, we need another function is sort yielding vehicles. Okay, this. And we sort the yielding vehicles based on right of way. Sort yielding vehicles, yielding vehicles. So this, when we have multiple yielding vehicles, we can sort it by using the right of way. The vehicle that goes straight should go first, and then turn right, and then turn left for the priority. So after we sort it, we can get the first yielding vehicle array. Next, we add another function is add vehicle to yielding chain. Add it here. Vehicle to yielding chain. Pay this. And this function, we make sure both vehicles have the same intersection. we add it to the yielding vehicle array to wait for the crossing vehicle to pass first. When we have normal driving, if f vector distance overlap location next intersection better than owner vehicle road network road width multiply with 2.5 and return. Use Spline component equal to owner vehicle get default spline find component by class use spline component if overlap vehicle and is capsule collision. This capsule collision will project along the spline path of the vehicle. Is vehicle aligned with spline component 30. If overlap vehicle yielding system to yield or overlap vehicle yielding system yielding vehicle is empty. We add vehicle to yielding chain. Overlap vehicle point spacing L resolve vehicle yielding status. So when the vehicle, we need to check if the overlap vehicle is red or is yellow. We add vehicle to the yielding chain. And if it is green, we resolve vehicle yielding status. Let's run this. And we go to BP traffic nature, connect to spawn temp vehicle 3. Play test. Now because we have the function add vehicle to yielding chain, so we can handle 3 vehicles in one intersection. Let's try found can be called vehicle 4. This is the scenario that I create. So we spawn 4 vehicles at different locations and then set the target location. Let's play. Now we have 4 vehicles intersect each other. And we wait for this vehicle to pass and then this next vehicle. And this is the last vehicle. Let's save this. Close. In some condition, we need to remove the yielding status from the vehicle, so the vehicle can proceed without creating the traffic jam. Copy this. Each other vehicle behind. Go to definition. Each other vehicle behind. When the yielding vehicle is behind the crossing vehicle, we should remove the yielding status from the yielding vehicle. We can copy this, remove blocking yielding vehicle, and reset yielding status function. Copy. We check if our vehicle is behind the crossing vehicle. So we reset the yielding status by remove yielding vehicles array from our system that should yield to false, yielding intersection location to 0 vector. Crossing vehicle, we need to set it to null pointer because we already driving normally. We check this when our vehicle is yielding. Or remove blocking yielding vehicle. Save. Vehicle yielding system. Copy clear yielding vehicles. And paste it here. Okay. We clear yielding vehicle. When our vehicle is yielding, we reset yielding status. And if it is crossing, we promote next crossing vehicle. Go to vehicle AI component base. And pick component. We set this yielding system clear yielding vehicle. We run this. We call spawn vehicles. And save. Now we can spawn the traffic and see if it is working. Let's play. So our traffic is working, but we need to make some adjustment for our project to make this traffic run smoother. You can see this red is this vehicle is yielding and this one is proceeding. Go to vehicle AI component. BP traffic manager. Get random target. Get random location on road. So we don't want to spawn the vehicle in the intersection area. So we need to change this method of using this input key. Delete this. Add variable Spline component. Change to Spline component. Object reference. And set Spline component. Check if it's valid. Next, we delete this. Get Spline component. Get tangent. Add distance along spline. World coordinate. Normalize it. It's become spline direction. And this spline component. Get location. Add distance along spline. World coordinate space. Set to spline location. Next, we get road actor. Get road width. Random. Load in range. Get spline component. Get spline length. Subtract it with this road width. And this is max. So we trim the start and the add distance of the line and check this road width greater than this spline length. If our road is short road, we use the center distance of the spline. Select float and we divide this line length by 2. If it's true, and then connect to this distance to find the tangent and the location. The same with this get random target location on road. We want to set the target to that isn't near the intersection area. So we delete this input key. Add variable Spline component, that is Spline component. Check if it's valid and delete this. We can delete this input key and we can copy this get location at distance along spline. We subtract the distance of the road width. Paste this next to spline location. Go to event graph and event arrive at destination. This we get target location on road instead of get random location on road and set as the target. Now we can play test this. And it is working, but we not yet have the avoiding obstacle line. If there is obstacle in front of the vehicle, go to vehicle AI component, go to reset spline immediately. Is default spline block. We set this last index to 3 and distance near this vehicle near distance change to distance along spline. And reset default spline. We can copy this and delete it. Go to reset default spline and delete highest input key. Find highest input key. This variable we stop using it because first we use it when we have the closed loop, but now our path don't have the closed loop. So we don't need to set this. And delete the variable. Next, we need to set up this reset spline immediately. Delete this. When it is valid, we can delete this. And disconnect. Create a sequence. Get yielding system. Should yield. Create a branch. We do speed trace by channel. From start to add location. The start location is actor location. And we get forward. Get actor forward vector. Add multiply. Float is 2. And connect to start. This forward vector we multiply with grid gap. Integer. Get grid gap. We want it to be forward a little bit. And this offset tangent location, we add it. With this value without multiply by 2. This is grid gap divided by 2 for the speed trace. We ignore the floor. Out hit. Break. Hit actor. Get component by class. And this component we call AI component. Check if it's valid. And if this speed trace overlap, create a branch. Because if we don't check this hit actor will be null, and then we cannot we will get error when we get component by class. When it falls, we set overlap to true. We can delete this. Next, we do box trace. Add the vehicle location using the box collision size. So box trace by channel. Because instead of using motion trajectory, we will use this box trace instead. Add vehicle actor. Get actor location. We move it a little bit upward. Plus 80. Make vector. X, Y, and Z. And this is start. You can check this box collision in the vehicle. This is the box collision. You need to adjust it to the size of the vehicle. Get box collision. Get box extend. And this is half size. Vehicle actor. And this is an actor rotation. This is the orientation of this tracing. And we trace with camera channel. Get floor actors. And ignore this floor actor. If it overlap, we set overlap to true. Next, we check overlap. If it falls, as we call overlap. Create a branch. Get overlap actor is valid. Is valid. Get component by class. We call AI component. We check this component to know that it is the vehicle AI or not. Is valid. And this component we can get yielding system. Should yield. And Boolean. This overlap actor. Get actor forward. vehicle actor get vehicle actor forward product less than 0.5. We do this because we want to know the direction of both two vehicles, our vehicle and the overlap vehicle. We add a branch. If it's true, we set overlap to true. If this has vehicle overlap to is false, and if the path is overlap, we add a branch. Set overlap to true. In this location, we check this when Goodyear is true. Move this node and we create a sequence in front of this Goodyear. Get avoiding vehicle. If it's true, is default line block. When it false, get spline actor not equal to default spline. If it's true, we reset default spline. So this, we want to know that when we are driving in the avoiding obstacles spline, if the default spline isn't blocking anymore, we reset to default spline. And next is return. Output avoiding obstacle. Get overlap and boolean. Get up and wait. Not boolean. And we return this avoiding obstacle to event graph. We add a branch and we reset path finding. duration is 1. We can reconnect this, analyze and map obstacle. Go to this, find target location, find by path index, and we can delete this branch and connect to this A star grid pathfinding. And we can play. Now we have this avoiding obstacle, but we need to disable debug. Go to vehicle AI component, debug grid, and disable this. Let's play. And now we have this avoiding obstacle line found when the vehicle need to avoid the obstacle. Before we use this motion trajectory to detect the static obstacle, but this motion trajectory we use box trace for multiple locations using polynomial regression function. This can cause a lot of performance because we already do the speed trace along the spline path, so we should only use one speed trace along the spline path. Let's delete this. Find motion trajectory component class member, and we find the location of it and delete the node related to motion trajectory. And remove execution pin path, and we can delete this variable. We can close this. Next, we delete this motion trajectory component. We have some reference, but we can force delete this and save. Let's update redirect reference. Go to we call AI component, event graph, get path overlap, has active overlap vehicle, not boolean. If the path along the speed trace along the spline is overlap and it is, then the active overlap vehicle, we do the avoiding obstacle at the branch, reset pathfinding when this true. Save. Open traffic tutorial.sln. We can open vehicle AI BP library .cpp and .h. Wait a little bit for Visual Studio to load this project file. We can delete this function, polynomial coefficient, predict future position. And go to vehicle AIBP library.cpp and find this error of this function, delete it. Save. Vehicle AIBP library.h. And vehicle AIBP library.cpp. We delete this agent. The same with build. We call AI build.cs. We add engine third party private static dependency agent. So we delete this. And we save. Next, run this project. We can go to BP Traffic Manager, and we don't need this spawn temporary vehicle. Delete all this sequence of spawning this vehicle. Only leave the spawn vehicle and set target location, arrive at destination. Next, we clean the project. Go to vehicle AI component. We delete some function that we stop using. Move to target. Delete its traffic block by save function. Terrain handling. Delete calculate sample point slope. If you delete the function that is using by the project, you get this warning, so you can click no. The same with variable component. Delete overlap vehicle. Debug control. Debug control, we stop using it, like this debug spawn spline, debug candidate, delete. Steering, delete your delta. Freeze actor location. Curvature, delete its vehicle ahead. And save. Next, we go to this vehicle AI component base, and when we spawn this capsule component, we don't want to see it, we need to set it to true. And save. Go to project and compile it. If you don't want to see the draw debug sphere, green, yellow, red, you can disable this, set it to false, then compile. And let's play. Press F11 for full screen. I made a mistake here. This box trace, this add location should set with the same location of the actor we call. Another mistake that I made is we do this peer trace and box trace when shoot year is false. So when the vehicle is yielding, we don't need this. Press F11 for full screen. So now we complete building this yielding system for our vehicle. Thank you very much for watching. If you like this tutorial, please hit like and please subscribe to my YouTube channel. Thank you very much for my patrons member who are supporting me. Your support really means a lot to me. See you in the next tutorial.